In today's lesson, we are going to be looking at determining the a value of a quadratic model. So in the past, or in their previous lessons, we've looked at graphing or from transformations, or basically graphing the vertex form, understanding what transformations are, graphing from the factored form, and now we're going to be looking at determining the a value of a quadratic model. So this is just kind of a continuation of kind of what we've been doing, coming up with an equation to kind of represent a quadratic function or a parabola. So first things we want to do in determining the a value of a model is what information do we know for sure about this parabola? What information do we know 100% we know the values of? Well, going through and looking, I know for sure I have an x-intercept here of 6, 0. And what I mean for sure is that I know for sure what the values are. Same thing over here, I know for sure there's a value of -1 for the other x-intercept. You could say, well, I know this is the vertex, and that's true, but I don't know the exact value, right? I know it looks like it's probably going to be 2.5, but I don't know 8.2, 8.3, I'm not quite sure. So I don't know that one 100%. I can also tell that I have a point here at 0, 4, and another one here at 5, 0. So basically what I can know for sure from this is that I have 4 points. I know the roots. Let me change the size of all this so it looks a little bit nicer. I know the roots. I know the roots or the x-intercepts are going to be -1, 0 and 6, 0. And I know that there are 2 points, or the points 0, 4 and 5, 0 are on the parabola. So I know that for sure. So based off of that information, what form of a quadratic equation do you think we should create to represent this parabola? We only have 2, right? Vertex or factored. So which one should we use? In this case, we are going to use the factored form. And the reason we're going to use, highlighter. The reason that we're going to use the factored form is because we know what the roots are. So we're going to use the factored form because we know the roots. So because we know the roots, we are going to use factored form. So let's start with our general form of the factored form. Our general form, f at x is equal to a x minus r times x minus s. That's the general form. That's straight from the notes. So that's our general form. Now we can plug in some information into this general form. I don't know a, and if you can kind of tell by the title of the lesson, that's what we're going to be plugging in or trying to find. I do know r. Right? R comes from one of the x-intercepts, or -1. Again, it's opposite of what we see. So if we see -1 as the actual root, it should be +1 in our equation. And similar to the next one, if I see +6, it should be -6 in our function or equation. So now I have a general form. I have an r and an s. I am missing my a value, however. So I need to find my a value. And how we do that is we substitute and it can be any point. Oops, I kind of made a mistake on this one. It shouldn't be 5, 0, it should be 5, 4. Small mistake on one of the points. Oops. So I need to substitute one of my points back into the equation. Right? I can use either point, doesn't really matter. I just can't use the roots again because I've already used those. But I can use either the 0, 4 or the 5, 0. I'm going to use the 5, or not 5, 0, the 5, 4. I'm going to use 5, 4 just so we have an example, because we might not always have the y-intercept. So in this case, I'm going to do an example where we can see when we have an x and a y. So substitute the point f or 5, 4 in for f at x and x, or basically sub it in for y and x. Remember, f at x, it can be replaced with y. So if I go through and do that, f at x or y is going to be 4, and that is going to equal a times 5 minus 1 or plus 1 times 5 minus 6. Now that I've plugged in a point, I can solve for a. So 4 equals a times 6 times negative 1. I get 4 is equal to a times negative 6. To get a by itself, I'm going to divide by negative 6 on both sides, and I get negative 4 over 6 is equal to a. I could also reduce it to negative 2 over 3 is equal to a. So once I have my a value, this is just basically saying now, therefore, right, the function is f at x is equal to negative 2 over 3 x plus 1 times x minus 6. So now I have my full function with everything filled out. We do the same thing with the next example. Again, what information do we know for sure looking at this parabola? Well, I should know for sure vertex of point 6, negative 3. Right, I can clearly see that point down here. And if we think back to the other one, we should find 2 nice points. Right? There should be nice points on our function or on our parabola. And again, by nice points, I mean they cross the grid line nicely. They give us nice values. So in this case, we have 1 and 2. And here we have 11 and 2. So what information do we know for sure? Well, we know the vertex is 6, negative 3. And we also know that the points 1, 2, and 11, 12, or 11, 2, sorry, are on the parabola. So based on the information that we have, what form of the quadratic equation should we create? If I want to come up with a model for this parabola, which form should I write it in? In this case, we're going to use the vertex form because we're given the vertex. The vertex form because we know the vertex. Right? In factored form, we do factored form because we know the x-intercepts or the factors. Right? So vertex form because we know the vertex. So this means that our function is going to look like f at x is equal to a times x minus h squared plus k. Right? So this is the vertex form is the form that we used with our transformations. I can plug in values that I know. I do know my h and k of the vertex. So f at x is equal to a times x minus 6 squared minus 3. So I have my h and k, but I'm still missing that a value. Right? So what we can do now, similar to the last one, we can plug a point. We're going to say 1, 2 into the, or not into, or just in for f at x and x. So similar to what we did before. So instead of f at x, we are going to write our y value of that point, so 2. So f at x, or 2, is equal to a times 1 minus 6 squared minus 3. 2 is equal to a times negative 5 squared minus 3. 2 is equal to a times 25 minus 3. I'm going to go through and solve this equation. I need to move the minus 3 over. This minus 3 comes over. So I have plus 3. It becomes, so 5 is equal to a times 25. Divide both sides by 25. And I get a is equal to 1 over 5. Therefore, my function is going to equal 1 over 5 x minus 6 squared minus 3. So again, just plugging our values back in, we have a value for a, h, and k. Everything's filled in. We don't have to worry about x, again, because x is for a general, any general kind of scenario. So we're leaving x and f at x alone. We're not filling anything in for that. So we can use this now with some application questions so we can come up with something to model them, right? So we kind of know, as long as we know some information about our parabolas and some points, we can determine an equation or a quadratic equation to model it. So the track for the main hill of a roller coaster forms a parabolic arch. The height of a passenger on the ride is given in terms of how far they are from the center of the arch. Determine an algebraic model for the height of a passenger according to how far they are from the center of the hill. So here we have to think about what form do we want to use, or what type of equation do we want to use for this quadratic. So we have our two options, our vertex or our factored form. In this case, we want to use our, well, we have to take a look at our points first, right? So we don't know for sure, but if we take a look at our points, we should see, okay, we start negative 18 meters from the center, the height is 0, and then we get closer and closer to the arch, and then we move away, and then we're 18 meters from the center, and our height is 0, right? So in this case, these two values here, zoom in to make it a little bit easier. These two values here, these are our x-intercepts. So we have two x-intercepts. So if we know our x-intercepts, we probably should be using our root form or our factored form. So our root form, we know our zeros. So we know our zeros, we know our roots, we should be using factored form. So if I take my factored form, so f at x is equal to a x minus r times x minus s. Oops. I'm going to plug in my two roots, x plus 18 and x minus 18. And don't just assume that it's just taking these two numbers, right? We take the opposite of what we see. So negative 18 for the one becomes plus 18. Positive 18 is minus 18 in our function. Again, we don't have an a value. So now what we have to do is we have to use any point, right? So we need to sub in any point for, say, y and x, or f at x and x, however you want to represent that y value. So we can use any point. For sake of argument, let's just say we're going to use this point here, 2 and 49.4. Again, it doesn't matter which one we use. Maybe you don't like the decimals, so you use something like 10 and 35, right? Or 14 and 20. It doesn't really matter what point you use. Any point will work as long as we're not using the x-intercepts again. So I'm going to plug in that point. So f at x, or the y value, is 49.4. That is going to equal a times 2 plus 18 times 2 minus 18. I get 49.4 is equal to a times 20 times negative 16. 49.4 is equal to a times negative 320 divided by negative 320 on both sides to get it by itself. And I get negative 0.154, we'll round it to there, equal to a. Now that I have my a value, now I can go back and write out my full function. F at x is equal to negative 0.154 times x plus 18 times x minus 18. And that is our completed function. So again, it's the same idea as the other examples that we did, just finding out whether it's root form or vertex form we're going to use, plugging in a point to find a, or solving for a. Last question, right? So a stone is dropped from a bridge 20 meters above the water. The height of the stone above the water as time passes is shown in the table below. Determine an algebraic model for the height of the stone as a function of time, h at t. So based off of my information that's provided, what should I be using, or what form should I be using? If I look at this, when time is 0, the height is 20. When time is 0.5, the height is 18.75. And it seems that the height's going down. We don't see any x-intercepts. We don't see when the height is 0, right, or when it hits the ground. However, what we do see, though, is we do see the highest point. Right, so in this case, because it's the highest point, that's going to be considered our vertex. Now, in some cases, it might be the lowest point as well, but right now it's just the highest point. So we have the highest point of our vertex, so therefore we should be using vertex form. So vertex form, because we know the vertex. So my vertex form in the form of h at t. So h at t is equal to a x minus h squared plus k. Again, that's just coming right from our notes. H at t equals, I don't know a, but I do know h. H is 0. So x minus 0 squared plus k, which is 20. So this is just coming from our vertex. Our vertex is the point 0, 20. 0 is h, 20 is k. So that's all that's doing. That's all where we're getting our points from. Now, what we're going to do is we're going to substitute in any point. So we're going to sub in any point for x. I guess it should be t. Sorry, if we're using t minus h, for using h at t. So any point for time and the height at a given time. So I'm going to use an easy one, or I'm going to use the only nice one here, 1 and 15, right? Those have nice numbers. There's no decimals, so I'm going to substitute those points in, right? So I'm going to plug in for h at t, or the height is 15, is equal to a times 1 for the time minus 0 squared plus 20. 15 equals a times 1 squared plus 20. Move the 20 over, I can find the squared first. 15 equals a times 1 plus 20. Move the 20 over, we get negative 5 is equal to a times 1, or just a. Now that I have that, I can write out my function. So therefore, the height at a given time is going to equal negative 5 t minus h, or I could just say t minus 0, or just t squared plus 20. So again, the main thing from this is just being able to recognize what form am I going to use, plugging in the known information, right? If it's factored form, it should be our x-intercepts. If it's vertex form, it will be our vertex. And then we plug in another point and solve for A. Right? So very similar steps, just depending on what form we're dealing with, determines the given information that we should be including before we substitute a point in.